Hi and welcome to this video on trial and error methods and also iteration. In the trial and error method or the trial and improvement method, we apply reasoning and try and find the solution using numerical methods. So if we have this cubic equation x cubed plus x equals 15 and we're told that the solution lies between 2 and 3, we can give an answer or an estimate of the answer using the trial and error method, and we make a table as such, use our 2 and 3 to get our answers. So it lies between 2 and 3. So 2, when we put the 2 as x into the equation, it's 10. The answer is 10, and that's too small when compared to 15. When we put 3 into our equation, we get 21, which is too big. So the answer or the solution that we're looking for lies between 3 and 2, somewhere between there. So let's look at 2.5. Let's take the midpoint. When we do that, we get 18.5. So it's too big. The answer is too big. It's bigger than 15. So obviously the answer is less than 2.5. So let's check with another number. Let's check 2.3. So when we put 2.3 in, we get 14.46, which is less than 15, so it's too small. So the answer lies between now 2.3 and 2.5. So let's take the midpoint, which is 2.4. When we take 2.4, put that into our equation, we get 16.32, which is too big. So we've got too small for 2.3, too big for 2.4. So obviously the answer lies between 2.3 and 2.4. So let's try the midpoint, 2.35. When we put 2.35 in, we get 5.32 as the answer from this equation, and that's too big. So 2.35 and 2.4 are too big. If we look at this on a number line, we've got the 2.4 here, the 2.3 here, 2.35 smack bang in the middle. So all these numbers here generate an answer or a solution that's too big. So the solution that we're looking for lies between 2.35 and 2.3. So it's going to be 2.31, 2.32, 2.33 or 2.34, one of those, we don't know which. But if we want the answer to one decimal point, then the answer is 2.3. Iteration. We've got this quadratic equation, x squared minus 5x plus 6 equals 0, and it's got two solutions. We can find the solutions by factoring, so we get the factors of plus 6, so two things or two numbers multiplied give us plus 6, minus 3, minus 2, and they also add to give us minus 5. So minus 3 and minus 2 are the roots, so we have x minus 2, x minus 3. If we set each of those to 0, we get the solutions as 2 and 3. We can also find these by iteration, and this is another method that we can use to find a solution. And it works a bit like trial and error, but it's a bit more mathematical. And this is how we do it. So iteration, it's a repeated process with the aim of reaching a target or a goal or a result. And the method is to rearrange the equation to make x the subject. So we take x onto one side and rearrange. Then we make the x, that is the subject, x subscript n plus 1. And then the other x in the equation becomes x subscript 0. We substitute in a value for x to produce our first result. And we're usually given this first x, x0, subscript 0 or x subscript 1. And then this answer that we get after this substitution, we substitute that back into our rearranged equation, into our iterative equation, and we get another solution. Then we repeat that step using the solution until this converges, the answers converge to the required degree of accuracy. So let's have a look at that. So we're going to do it for this quadratic that we had, x squared minus 5x plus 6 equals 0. And we take the equation and make x the subject. So x squared take the 5x to the other side, becomes minus 5x becomes 5x, take the 6 to the other side, becomes minus x. So we've got the x squared here, make that into an x, we square root the other side, do the opposite of squaring, so square root of 5x minus 6. Then we put the subscripts in, so this x on this side, which is now the subject, becomes x subscript n plus 1, and this x on the other side of the equal sign becomes x subscript 0. Then we substitute our values in. So say we were using our value as 4, so this x2, x subscript 2 becomes, we substitute the 4 for this x, becomes 5 times 4 is 20, minus 6 and the square root of that, which is 3.7416, etc. That answer then goes into the same iterative equation, so it becomes x subscript 3 equals 5, and then this answer multiplied by 5, and then the square root of all that minus the 6, don't forget that. And this is the solution we get, 3.5648, etc. Then this answer we put into our x subscript 4 iterative equation, and that is this same equation here, but this now is x4, so this is going to be this answer, 3.5648, multiplied by 5, minus 6 square root, and we get 3.4386. And as we can see, these answers are converging, and if we carry on going to about x subscript 8, x subscript 9, the eventual answer will converge to 3, so we can work out this root as 3. Here we're asked to find the solution to x cubed plus x equals 15. Make x the subject, we get x is 15 minus x and then the cube root of that. Put in our subscripts for the x and this x subscript 0. And then we use a number, say 3, as our x1 to begin with, get our answer. The answer then goes into here, our x subscript 2, and then the answer to that goes into here's our answer to x subscript 3, and we can see that this is now converging to 2.3, so the answer is x equals 2.3 to 1 decimal place. So again, following our method, let's do this example of iteration. We want to find the solution to this 2 to the power x equals x to the power 3. We can do this graphically by drawing the two graphs. So here we have the graph of y equals 2 to the power x, and here we have the graph of y equals x cubed, and where they cross, which is about here, which is between 1 and 2, that's our solution. So if we want a more accurate answer, we can get that by iteration. So let's rearrange this to make x the subject. So x equals the cube root of 2 to the power x. Let's put in our subscript to make the equation into an iterative formula. So we get x subscript n plus 1 equals cube root of 2 x to the power 0. So 2 to the power x subscript 0. So let x1 equal 2. So because we know this is about 2 here. So x2 becomes 3 to the power 4, 2 to the power 2, where x1 is 2 is 4. So that's our first solution, 1.5874. Then our x3 then becomes cube root of 2 to the power of this answer, which is 1.5874, which equals 1.4429. And we find that eventually the x converges to 1.37 to 2 decimal places. So we continue this using this answer x as x power x to subscript 4, and then x subscript 5, and then eventually we find that x converges to 1.37 to 2 decimal places.